yet. I'm still thinking whether I should do or not. It'll happen only online. Basically, we have this one. Aribajit, what do you call? We have the election 2 days, right? So probably I'll be jobless on those 2 days. No. Then I thought, what do you called? On those two jobless days. Let's see. I'm still thinking. I'll post the details. If it's finalized, I'll post the details probably by before Thursday, inshallah. Let's see. I'm still finalizing stuff. Let's see. I probably should have it. Zuha just drop a WhatsApp message to this number. Why do you change the time from 7:30 to 5? Thursday class. Yes. I told the reason in the class. I'll tell later. How do we have to buy any tube for the paper? If you're my theory class student, you'll be getting the tube completely for free. The thing is, I have given the tubes to print. I didn't get them yet. So all my tubes are being printed. That bugger said only half is printed. So once I get it from printers, I'll give it to yours. And the paper class anyway is completely free until orders. So there'll be the only paper class coming students. You will be getting a soft copy of the tube. But if you want the hard copy, I can arrange something. Just give me some time. After I get the printed copy, I will let you all know how you all can obtain the printed tube. I'll arrange some method. Okay. Anyways, I guess we can start now. I think I've solved everything. Yes. Let's begin. So last week we started discussing certain questions, and primarily we talked about questions related to arrays because that was the question we got. The second question is also regarding arrays. Let's go for something new. Let's go for something fun, and then I'll come back to that. Okay. Let's look at this question. So how the paper? So if there's anyone new for the paper class, just tell you how it works. Paper class will work is I'll be sharing you all a question. I'll screen share a question, and you all are supposed to have a writing book with you. That you are supposed to have a writing book with you at the moment for now. And on that writing book, I want you to note down the answers. So you'll be writing, for example, 2018 oral paper, Roman number 9. Actually, this is question number 1, Roman number 9. And you will have to answer the question. So after 10 minutes time is over, now this is actually not a 10 minutes question. So certain questions are there 5 minutes, certain questions are 10 minutes. I'll give you a bit more time sometimes depending on the question. So once your time is up, I'll start discussing. So when I'm discussing, I want you to correct your answers using a red pen. So right answers is avoid black pen. Okay, write your answers using blue pen. That's fine to use black, but preferable blue. There's a reason for that until later. And correct your answers using red pen. That's the way it's going to go. And I'll give you all 7 minutes. It's 38. So I just give you all 7 minutes. You're on the timer. I want you to answer this question. What you call 2018 oral papers part 2. Questions part. I'll give you all around 7-8 minutes. Start answering. Should we write the question? Don't write the question, just write the question number only. Can write the question number only and directly start answering. Let me on the timer. Okay, timer is on. Start doing the questions out of here. Are there any questions after the chat? Huh? Are we doing only programming questions? In the beginning, which means for the first 1.5 months of first 2 months, we'll be talking about programming questions only. And once we're done with the programming questions, then we'll be going to mixed questions. Like we'll be doing spreadsheet, database. On the same day we might do, and then we might do random questions. It's going to be mixed once we're done with programming. So only programming is going to go lesson wise. Once programming is over, we'll go mix. No, no need. What do you mean by phase five? Walaikum salam. Ah, you mean worksheet? Okay. Worksheet. Sorry. So I just drop a WhatsApp message to this number. It's also that's fine. Ashra. Doing this question for that 5 minutes training. Didn't I reply? No, Rashida. Ah, okay. This is from yes. Wednesday. Next time is still by mistake. We'll check. Do I send it to you after the class is over? Something like that. By what time is it over? Sorry. How to find product? Product means multiplication. Let's try this. Try. I'll explain why. How to do it. Yes, Shaham, I have. Can I have 1 minute remaining? Think so. Okay, your time is up. 3, 2, 1, plus. Let's check the answer. Okay. So this question is saying, consider the given flowchart that finds the product of an integer with all the integers below it. Okay, they are saying something about the flowchart is going to find the product of an integer with all the integers below it. So how much for now for the first 2 months? And they have mentioned here if n is a given integer, then the product of okay, they're saying if n is a given integer, then the product of integer is going to be 1 times, 2 times, 3 times, blah blah. Okay, for example, it's something like this. For example, they're going to ask the user for a value. For example, let's say he gave the number 4. If the user gave the number 4, you're going to find the product of numbers below it. It means when you use the word called integer, what we're meaning by here is whole numbers. Huh? The word integer here is meaning whole numbers. So when they say you're going to multiply that with the whole numbers below it, what we are meaning here is from 4, when you go backwards, the whole numbers we have are 1, 2, 3, and 4, right? So what's going to happen in this program is it's going to multiply with all the digits. It's going to multiply all the digits below the number entered, and it's going to give you the answer. Like for example, if the user inputs 4, then the output would be something like 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 6, 8, 24. 24 might be the output, something like that. That's how the program is going to work, is what is mentioned in this line. Before you start answering the question, tell me, before you start answering the questions, are you clear on what this question is asking or what this program is used for? Did you understand the purpose of the program? Yes or no? Can you repeat it, please? Yeah. So the purpose of the program is we're going to ask the user to enter a number, right? And once the user enter a number, you're going to return or you're going to display back after you get a number from the user. You're going to display back the product of numbers below it. When you say product of numbers, what the word product means multiplication. So we are saying we're going to give the product of numbers or we're going to give the multiplication of the numbers below it. Like for example, if the user enters number 5, below 5, what are the whole numbers we have? Or what are the positive whole numbers we have? Less than 5. Correct. The positive whole numbers less than 5 are 1, 2, 3, 4. So what the question is saying here is the flowchart is going to find the production multiplication of an integer, multiplication of a number. That means multiplication of the number you're going to get from the user, multiplication of that number with all the numbers below it. So you're going to multiply 5 with all the numbers below it, which means you're going to multiply 5 by the numbers below it, 5 times, 4 times, 3 times, 2 times, 1. Okay. So if the user gives 5, you're going to multiply that 5 enter by all other numbers below it, and you're going to display back the answer. Like for example, user enters 5, 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is 120. 2 times 2 is 2, 2 times 3 is 6, 6 times 4 is 6, 24, 24 times 5, 120. Yeah. This is going to be the output. Did that make sense? You're going to ask the user a number, and once the user gives you a number, you're going to multiply that number with all the numbers below it and display the answer. Make sense? Who is the user? The user is the person who's going to use the program. When you say programming, we're going to create a program. Like we're going to create an app. So anyone who's going to use this app is a user. Perfect. Now look at this question. We look at the flow chart. The question is mentioned, write the correct expression for L and M. Okay, let's look at the flow chart first of all. How do we know that we have to multiply by 5? I said example. So I took 2 examples. So basically, when you say that what you call input N, what's happening here is we're asking the user for a number. So user can enter any number he wants. And in programming, what we're doing here is we're going to create a dynamic program. So there is a word called dynamic programming and static programming. When you say static, that is what your question is referring to. You're saying, how do we know the user is fine? Like, for example, if the question had told what you call create a flow chart that displays the multiplication of all numbers less than 5. Now, when you say multiplication of numbers less than 5, definitely you know that 5 is going to be the first number, and you're going to multiply by 4 and 3 and 2, and the answer is going to be 120. Now, you know the exact answer. But when I say, what do you call, create a program that multiplies the numbers, like gets a number from the user and multiplies the numbers less than it. So now we can't predict exactly what's the number user is going to enter. If the user wants, user can enter 7, user can enter 5, user can enter 4. It can be any number the user enters. And depending on the number the user enters, your program has to work. So you write a logic in such that any number the user enters, based on that number the user enters, the program will work. Makes sense? So they haven't mentioned a specific number that was entered by the user. Exactly. We don't know what number the user is entering. So we have to make the program in such that user can enter any number he wants. Like for example, let's say something else. Let's say I ask you to make a program that's going to ask the user a number. Okay. Let's say he's going to ask the user his phone number. Let's say this program is going to be used only in Sri Lanka. Okay. So let's say a 10-digit phone number. And once the user gives his phone number, let's say you have to tell, is a phone number entered, is it Mobitel? Or is it Dialog? Or is it Airtel? Or is it Hutch? Can you tell? Now, if you were supposed to do this, is there some logic on how your brain works to categorize a phone number as Mobitel, Dialog, Airtel, Hutch? Is there a way you can categorize them? Let's say if I give you a phone number, by looking at the number, is it possible for you to tell what type of number is it? Is there like a logic that's behind it? Exactly. You know the first 3 digits, right? The first 3 numbers. Like for example, out of the 10 digits, all, whether it's Mobitel, Dialog, Airtel, or Hutch, all these numbers will start from 07. Okay. Let's say there is a phone number that's there in the range of 070 1 2 3 4 5 6 7 8 9 10. So there are 10 digits here starting from 070. Now 070 numbers, whether 070 blah 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 or 070 111, 070 222, all these numbers are responsible for what? But cellular partner. These 070 numbers are exactly 070 numbers are Mobitel. Then 071 numbers are 071 is also Mobitel. So you can tell if a number is there in this range 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. You can tell if a phone number is there within this range. If the number entered, if that number entered is within this range I have mentioned here, then definitely that number is what type of number? Exactly. If it's going to be there in this range, it's definitely a Mobitel number. Now here, if you look at this program, what's going to happen? You're going to ask the user to enter a specific phone number, at least 10 digits. Now, do you know exactly what is the number user is going to enter? Whether he's going to enter Mobitel, Dialog, Airtel, Hutchkira. By default, do you know what number he's going to enter? No. By default, we don't know what number. So how this program has to work? We have to ask the user a number, and then we are going to check, is the number there in this range to classify as Mobitel, or is the number there in this range? For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0, 7, 5, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or is it there in this range to classify as Airtel? So likewise, depending on the range this number falls, only we are going to classify as whether it's Mobitel, Dialog, Airtel, or Hutch. So before we start the program, we don't know. We are going to ask the user number and we are going to do some kind of a calculation. We are going to do some kind of a processing. And based on that processing we do, we are going to classify. Similarly here also, we are going to get a number from the user and we are going to do some processing here. And depending after that processing is done, we will be able to find out the the multiplication, the product of numbers below it. Did that make sense? I seriously did not know the brands are difference in their phone number. See. Mobitel numbers are normally between 070 and 071. Dialogue is 074, 077, 076. Yatel is 075. Hutch is 072, 078. 012, 073. I don't think anyone has yet. I can't remember. 4, 5, 6, 7, 8. 073 and 079, I don't think anyone has, as I can remember. How to ask the number from the user? That is what we have here as statement. Input n. I'll buy those. Why are you there here? I know this stuff only today. She. Sad life. Yes, sir. Okay. So if you look at this program, what's going to happen is you can see the first instructions input n, which means, yes, I have to skip a new part, this one, which means we're going to ask the user, hey, user, give me a number, right? The input n is, it can be anything. Huh? Input n means it can give, and you ask the user to give something. When you say the word input, okay, normally if you take a program, I think a program as like an application. If there's anything, you have to give the application. Okay, if there's anything you have to give the application, we call this as user. If there's anything the user is going to give the application, we call it as an input. And if there's anything the application is going to give back the user, how do we call that test? Perfect. If there's anything the application is going to give the user, we consider that as an output. Okay. So when you want to ask the user a value, it's always an input, right? So apart from using the word called input, there are other keywords you can use as well. I'm not going to talk about that. It's unwanted for today. So when you say input n, we're going to ask the user for a value. That value can be a number, it can be a name, it can be a what do you call color, or it can be anything. Just we want some value from the user. Okay. Yeah, honey, that's fine. So when you say input n, we're asking the user a value. And what happens is the value the user is going to give us, we're going to store that value under the name called n. So okay, when you're going to store a value under a name, we call them as using a special words. What is the word we use to call these like letters like this letter n? Where we're going to ask the user a value, and the value the user gives, we're going to store it inside a letter or a name or a word. So if you're going to store a value inside a word, what do you call it as? Perfect. That's called variables. So here n is actually a variable. In this variable called n, I'm going to store the value the user gives, right? That means the number which I want. For example, in this example I told you here, the number 5 the user is going to give, right? That 5 I'm going to store in n. Then you can see there are two other variables I have mentioned here. There's a variable called p and there's a variable called q. Now I know n variable is used to store the number the user want to enter, which means in my example is number 5. Okay, in my example, let's say like 5. Now I am confused what is p variable and what is q variable. If I just go through, I can see that p variable is used here, q variable is used here, and p variable is used at the end as well. So just before the program finishes also, we have the p variables. Now practically, if you look at this whole scenario, if you looked at the example we saw, we asked a user a number. And once we're done asking the user number, at the end of the program, once we're done calculating in our head or paper or whatever, once we're done calculating, we are going to give the user the product. The product means the word product means multiplication. We're going to give the user so if user gives 5, we are going to give 120. So technically, if you say display P here, that means this P is going to display that product of numbers. In our example, if the input was 5, what do you think the product has to be? If the input was 5, what's the output the P is going to be? Exactly. If n is going to be 5, the input is going to be 5, then the product is going to be, as per the example you can remember, it's 120. Now still we don't know what is Q. Okay, when you go through the program only, we can figure out what is Q. Normally, imagine I think I told this last class as well, I can't remember. Imagine you're going to run a race around the ground. When you're running around a race, let's say this is the starting of the race, the start line. Let's say the grounds is 100 meters ground. The grounds is 100-meter ground. You're going to run a race, which is a 400-meter race. if you're to run a 400-meter race, how many rounds are you going to go around the grounds? Yes, that's exactly. You're going to run a race around these grounds. You're going to go 4 rounds. Now imagine when you're running around the grounds, you're going the first round. Huh? When you're going the first round, should you keep in your mind, okay, inside I doubt if you'll have a brain, but let's say you'll have a brain, this is your brain. Should you keep inside your brain the count on how many number of rounds you're running? Is it an important data to keep in the head? Which round are you going? Are you still in the first round or second round or third round? Is it important to keep this in your head? Yes. Those who don't have brain, they'll say no. Because why? They're not keeping in their head. Exactly. Okay. So you'll be keeping in your head what you call, okay, we are in the first round. And when you're about to start, just before you start the second round, you will be getting a question in your head. The question you will be getting in your head is, okay, I'm at start line now. Should I go for the next round? Which means, should I go for the second round? Then you're going to ask yourself the question, should I go for the second round? Your head will be like, yeah, we have to go. Then you're going to again go the second round. Then in your mind, you'll be like, okay, I'm in the second round, I'm in the second round, I'm in the second round, I'm in the second round. You'll be running. Again, when you're close for the starting line, your head will ask you a question. Should you go for the next round? Which means, should you go for the third round? Again, your head will be like, yes, and you go for the third round. Then once you're done with the third round, again, your head will ask you a question. Should you go for the fourth round? Then again, you'll be like saying yes, and you will go for the fourth round. Once you're done with the fourth round, your head will ask another question. Should you go for the fifth round? Then what should be your response? Yes or no? Should you go for the fifth round? No. So if you notice here, when you're running around the ground, you're keeping in your mind the number of rounds you're going. In your brains, you're keeping the idea of the number of rounds you're running. Okay. And what is the purpose of this? To make sure that you follow the instructions the exact number of times, so that you don't run more number of rounds, you don't run less number of rounds. To make sure you run the exact number of rounds is an important data. Similarly, when you're following instructions, when there is a certain set of instructions, when there is a certain set of logic, it has to be repeated. Now, if you notice here, this part of the program is a repetition structure from here to here and here. This whole thing is actually a repetition structure. These instructions are going to be repeated again and again and again. So when you're having a repetition structure, it is important data to know the number of rounds or the number of times you're going to execute. And what is the purpose of that? The purpose of knowing that is make sure that you stop at the correct time. Okay, just like running around the grounds to know exactly when to stop. That's the main purpose here as well. So the main purpose of what you call knowing the repetition structure, the main purpose of knowing the number of rounds is to know when to stop. So if n variable is going to use to store the number entered, if p variable is going to use to store the product, then definitely what do you think q variable is going to use to store them? Output is stored in p now. See, display p, that's the output. So q is stored in the number of rounds. Let me tell you how the number of rounds is going to apply here. Initially, you can see p is equal to 1 and q is equal to 1. Fine. Let's forget about that for now. You can see when we are starting itself, we are going to ask here, is q greater than n? Which means the number of rounds we are going to start. Again, you can see here the number of rounds we are going to start. Still, we not starting on one. So we are going to ask the number of rounds we are going to start. Is it greater than the number entered? For example, in our scenario, let's say is 1 greater than 5. Okay. Now, when you ask this question, is 1 greater than 5? Tell me, what is your answer? Yes or no? If someone asks you, is 1 greater than 5? What will be your answer? Yes or no? Exactly. Your answer is going to be no. So then what you're going to do is you're going to go for the next instruction, to this instruction P. So what's going to happen here is you're saying P is equal to something. Now, for example, when I got this answer 120, I knew, okay, I was able to identify the numbers below 5 is 1, 2, 3, 4, 5. Okay, I was able to understand 1, 2, 3, 4, 5 now. But when I was calculating 120, just by looking at this number, did I tell, okay, 5 times, 4 times, 3 times, 2 times 1, the answer is 120. Did I tell the answer at once? Or did I calculate it pair by pair? When I say pair by pair, did I calculate saying, okay, 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 122, 120 into 1, 120. Did I go pair by pair or did I go at once? How did my brain process this? Exactly. Brain, it will process it pair by pair. It'll take little by little. Okay, that's how your brain process. So similarly, in this program also, you're going to do that kind of answer. To get this answer 120 without getting the answer 100 directly, you're going to multiply it little by little, little by little, little by little. Let me show you how you're going to do it. So how you're going to do it, first of all, you're going to say, if you notice here, initially, let's say P was 1. Initially, let's say P was 1. Okay. So what you're going to do is you're going to multiply P by Q. Let me elaborate this. Okay, I'm saying P is going to be equal to P into Q. First of all, I tell you the meaning of Q, then only it will make sense. Okay. And I'm going to say Q is going to be equal to, after I'm done with that multiplication, after I'm done with this multiplication, I'm going to say Q is going to be equal to Q plus 1. Zainab Narim, that's example. I'm going to say Q is going to be equal to Q plus 1. Okay. This is still the example, right? Yes, it's example. Okay. So I'm saying Q is going to be Q plus 1. Now, let me tell you why I put those two there. Now, initially, when the program started, look at this box and tell me what was the value of P and what was the value of Q. Initially, when the program started, what was the value of P, what was the value of Q? Perfect. P was 1, Q also was 1. When I say P equals P into Q, normally when you have an equation like this, always keep in mind in an equation, we are giving a value for the left-hand side person. So we are saying, okay, we are always giving a value for the left-hand side person. Huh? So we are saying the value of P is now going to be equal, which means the new value of P is going to be equal to the current value of P multiplied by the current value of Q. Look at the table I drew in the bottom here and tell me, if I multiply the current value of P and the current value of Q, if I multiply those two values together, what's going to be the new value of P? Perfect. That's going to be 1 times 1. Again, that's going to be 1. So basically, the value of P is 1. There is no change. Now, when I go for the next instruction and say Q equals Q plus 1, again, same idea. Left-hand side, we are saying the value of Q is going to be equal to the current value of Q plus 1. So currently, Q is, at the moment, you can see it's 1 now. Based on that, tell me, what will be the new value of Q after I do this calculation? When I say Q equals Q plus 1, after I'm done with the calculation, what will be the value of Q? Perfect. Currently, Q is 1. So Q plus 1 means 1 plus 1. That's going to be 2. So the value of Q is 2. Now, if I follow the chart and go for the next instruction, the next instruction is saying, is Q greater than N? Currently, Q is 2. I said for example purpose, let's consider N to be how much? For example, N is going to be how much I told you? Yes, I said for example, let's consider N to be 5. Okay, but N can be any other numbers as well. For example, we are going to consider N to be 5. Now, when I go and check, is Q greater than N? Q is now 2, N is 5. So if you ask the question, is 2 greater than 5? Yes or no? It is no. So because it is no, you're going to come for this right-hand side. And we're again going to come to this instruction. This P equals P into Q. Look at the current value of P. Look at the current value of Q and tell. Multiply P into Q. What will be the answer? Perfect. P is 1, Q is 2. 1 times 2 is 2. Now when I go for the next instruction, Q equals Q plus 1. Currently you can see Q is 2. When I say Q equals Q plus 1, what will be the new value of Q? Perfect. The new value of Q is going to be 2 plus 1. That's 3. Then again, if you follow the line and go, you're again going to come for this line instruction. Is Q greater than N? Look at Q greater than N. Yes or no? Again, no. So we're going to come for the right-hand side. When you come to the right-hand side, we have P equals P into Q. So 2 times 3 is 6. Then Q equals Q plus 1. That's going to be 4. And if you go for the next instruction, again, you follow the line and go, is Q greater than N? Is 4 greater than 5? Again, no. So again, we're going to repeat. Again, if you repeat, P equals P into Q. And 6 times 4 is 6, 12, 18, 24. Q equals Q plus 1. That's going to be 5. Again, if you come and check, is 5 greater than 5? Yes or no? Now when I'm coming, is q greater than n? Q is 5, n is 5. When I go and check, is 5 greater than 5? Still no. So I go for the right hand side, then P equals P into Q. When you say P equals P into Q, P is 24, Q is 5, 24 times 5 is 120. The next instruction, Q equals Q plus 1. So Q plus 1 means it's going to be 6. Now when I come and check, the next instruction is Q greater than N. When I go and check, is 6 greater than 5? Yes or no? Yes. So if I come down, you can see display P. Look at the chart and tell me, look at this table and tell me, currently what is the value of P? Again, when I say what is the value, check the columns, last value. Huh? So what is the value of P now? P is 120. Exactly. So when you say display P, the output is going to be 120. You can see the same thing I did in my mind as well. When 5 was entered, 120 was displayed. And how did my mind proceed? I multiplied 5 times, 4 times, 3 times, 2 times, 1. Okay. Now in this program, they're going from not from behind to front, they're going front to behind. Like for example, you can notice here, they are multiplying 1 times 2. So 1 times 2 only, this 2 came here. Then 2 times 3, that's how 6 came. Then 6 times 4, 22. And 24 times 5, 120. So they are actually going from 1 to 5, not 5 to 1. But see, the answer was processed little by little, little by little, little by little. For multiply, should be mentioned star or x star. Anyways, so if you look at this program, what's going to happen here is this q equals q plus 1, that is going to increase the value and notice the number of rounds we're going. In this scenario, why do we need that is because, but how this program is going to work is, it's going to take the number the user enters, and it's going to start with 1, and it's going to go up to that number. For example, initially q, and let's say number entered was 5. First q will be 1, then q will be 2, then q will be 3, q will be 4, and q will be 5. So from from 1, it's going to go up to the number entered. Something like that. And little by little, what you're going to do is you're going to multiply that with the product. That's how this program works. What is the meaning of M and L? That's what I've written here below. L is representing P into Q, M is representing Q plus 1. Why do you multiply P into Q to get L? Is there any other ways you can get? So I was like thinking practically how you're going to do that. Practically, if your brain is supposed to multiply, how did your brain multiply? Like for example, I said when the user entered 4, how did I multiply? First I multiply 1 times 2. So 1 times 2 is 2. The answer I get, I'm going to multiply by 3. So 2 times 3 is 6. Now the answer I get from here, 6 times 4, I'm going to multiply. 6 times 4 is 24. And that's how I get 24. Right? So what's going to happen is you're multiplying two closer digit, and the answer you're going to multiply the next digit. The answer you're going to multiply the next digit. So the answer is what I'm storing in P. Next digit is storing in Q. So answer into next digit. Answer into next digit. That kind of idea. Makes sense? Wrong answer. Initially, it might sound hard because it's the first time you're doing such programs. But once you practice more and more programs, it will be like water. Because the thing is, you should, if you know how it works, like how a program works, like think like a program, if you do that process, it'll be easy. Not very recently. What's the answer for this question? So the question is, what's the correct expression for L and M? L is going to be representing P into Q. M is going to represent Q plus 1. That's the answer for A. Makes sense? There's always a logic and like a pattern, right? If there is a pattern only, you can do repetition structure. If there is no patterns, you can't do repetition. Like always, try head. You always, what you do is you try to decode your head, how your head will work. When you want to decode your head, there are 3 things you have to figure out. It's the first thing you learn when you start this lesson. When you start the program lesson, can we learn something called how to analyze a problem? To analyze a problem, we need 3 things. What are the 3 things we need? Where is it stated? It is not stated. I defined it. Yes, you need to know 3 things. One is the input needed for that. Second thing is process. And third thing is output. Now, in this scenario, they said when you take a number, it should return the multiples of the numbers below it. So, for us to do a testing, for us to perform a test, okay, for us to test an idea or test a program, we need sample data. Like, for example, imagine you're going to do a scientific experiment. You're going to do an experiment saying, can plants, do plants need oxygen What do you call do plants need oxygen to breathe? Now, if you're going to do this practical, you need something, right? You can't just imagine, okay, let's imagine a plant. Okay? You need an example of a plant, right? Without using that example, only you're going to perform the calculation. Similarly, when I'm going to create an idea, when I'm going to create a logic, I need some example. So what I'm going to do is I'm going to say, okay, let's say the input. For example, again, I'm using the word, listen to my words. I'm again using the word called example. Let's say, for example, the user is going to give us 5. Now I'm going to say, okay, if the user gives us 5 and you want to multiply, the question says what? The program has to multiply the number entered by the numbers below it. So now I'm going to ask my question, okay, what are the numbers below it? The numbers below it is 1, 2, 3, 4, 5. The numbers below it is 1, 2, 3, 4. And what the question had told is you're going to multiply the number entered by the numbers below it. Okay, the numbers entered, you're going to multiply it by so let's say this is the number entered. And let's say these are the numbers below. So the question said it has to multiply the number entered by the numbers below and give the answer, which means the question is saying the output has to be 1 into 2 into 3 into, okay, you're going to multiply the number into the numbers below it. So now I'm going to ask my head, okay, how will my head process my head going to find the answer? This is called process of decoding how your brain works. Now, when you're going to find the multiplication, if you are supposed to find the answer, first what will you do? Will you multiply 1 times 2 first, or will you multiply 5 times 4 first, or will you multiply 2 times 3 first? Practically, if you get this, if someone asks you to find the answer, your head will go and multiply what and what first. Exactly. If this was the equation given to you, you might first of all normally start with 1 times 2. So now you know 1 times 2 is how much? 1 times 2 is going to give you 2. Now you multiply, let's say you have multiplied 1 times 2 and you have the answer is 2. Now you're going to multiply this 2 with what? Like if this was a question given, when you're finding the answer here, you're going to multiply 2 by what? Exactly. You're going to multiply this 2 by 3. So when you multiply 2 and 3, what's the answer you're going to get? Correct. 2 times 3 is going to give you 6. Now you're going to multiply this 6 by what? Perfect. You're going to multiply this 6 by 4. So 6 times 4 is going to give you how much? Exactly. That's going to give you 24. Now you're going to multiply this 24 by what? Perfect. You're going to multiply this 24 by 5. And 24 times 5 is going to give you 120. Now, if you notice this, without your intention, there is a pattern. What is the pattern? Multiply the number or multiply the answer by the next digit. Okay, you can see, for example, if you start from here, you're going to multiply the answer you get. 1 times 2 is 2, you're going to multiply 2 by 3, the next digit. So the answer you get from that is 6. So the answer you get, you're going to multiply the next digit, that's 4. 6 times 4 is 4. The answer you get from that, you're going to multiply by the next digit. Okay, and you get the answer 120. And you stop this in which situation? When the next number is, so let's say now, for example, you can see here, I multiply the answer by the next number. No? So you stop this pattern when the next number is when the next number is equal to the number entered. So this is how you determine, okay, right, there's a pattern here. So there's same thing repeating. Multiply 2 digits close by, the answer is the next number, answer is the next number, answer is the next number, answer is the next number. And how you do it now, what you do is you see that can you decode this? Can you make this like a process? Can you make it to be done step by step? If you do that, yes, you can make it done step by step as well. How? For example, you have to figure out, is there a way that I can get this 2? Like, no, you have this 1 times 2 is 2, right? That's how you got this one. No? You have to figure out, is there a way that I can know, I can get this as well, this number, the first number as well. So what you can do is, okay, let's set extra one more step. By that, the answer has to not change. Huh? So what I'm going to do is, without just directly starting 1 times 2, I'm going to start like this, 1 times 1 into 2 like that. Now, if I do like this, 1 times 1 is going to be 1. And I'm going to multiply 1 with the next digit 2. And 1 times 2 is 2. And I can say, okay, 2 has come here. Right? Then 2 times 3, blah, blah, blah. Till I can go on the pattern. So if you notice this pattern, you can see there's a pattern from the beginning to the end. There's a pattern going. So what happens here is the same idea I'm breaking down into a symbolic format. And what I'm going to say is, I'm going to say, okay, let's say this 2, 6, 24, 100 when I wrote in red color. Let's say we're going to store that value in P. And the next digit, that is this 2, 3, 4, which I have here, the word next digit is there. I'm going to say, let's consider this word next digit as Q. So initially, I'm going to say P is going to be equal to 1. Okay, initially, I'm going to say P is going to be equal to 1, which means this. And now what I'm saying, when I say P equals P into Q, I'm going to say Q is also equal to 1. Okay, let's say Q is going to be the next digit. Q is also going to be 1. So it's like I'm saying equals 1 times 1. Okay. And what I'm saying is, let's create an equation saying P equals P into Q. And let's keep on multiplying that for every digit we have. And once we're done multiplying, okay, you can see once we're done with the multiplication, once we find 1 times 2 is 2, once we're done with the multiplication, let's go for the next number. So which means let's increase the value of the next number. Once we're done, 2 times 3 is 6. Now we'll go for the next number, which means increase the next number by plus 1. See, plus 1. See, there's a pattern here. The next, always the next number is going to be, the next number is this next number which is happening. There's a pattern of how we go for the next number. We are multiplying and going for the next number, multiplying and going for the next number. So what I'm going to do is I'm going to say, okay, 1 times 1 is going to be 1. Fine. So by this, I get this answer. Okay. Once I'm done with the multiplication, now I have to figure out the next number. So what I did is, I'll be like, okay, currently P is 1. So Q is 1. The next number after 1 is 2. So I write Q is 2. Now I multiply 1 times 2. 1 times 2 is now 2. Then I got this answer 2 here. Now, okay, once I'm done finding the answer, now I have to figure out what is the next number. To find the next number, again, plus 1. So after 2, next number is 3. So initially how this worked was, I had 1 times 1, then I multiplied by 2, and now I have written 3. Okay, now I multiply 2 times 3. 2 times 3 is going to give me 6. So once I have 6, once I got the 6, now I'm going to figure out what the next number is. Next number is what? 3 plus 1. So 3 plus 1 is 4. And once I'm done with the multiplication of 4, 6 times 4 is 24. So once I found 24, now I have to figure out what's the next number. Next number is what? 5. So plus 1. Once I'm done figuring out 5, now I will multiply 24 times 4. 24 times 4 is what? 120. Now because I repeated this as a pattern, the next number after 5 is going to be 6. So when I reach 6, I should know, okay, once I reach 6, I have found the answer is 120. So I have to stop my program. So that is how I determined I had to keep that condition as if Q is greater than the number entered. See, all these time Q was less than the number entered. Once Q becomes a greater number than the number entered, stop the repetition and display the value of P. How do you know the meaning of P and L? I'm breaking down my brain. So I was just, again, I tell you this now, this is the first time you're doing a hard programming question. Some of you all might be not first time, but majority. So this is not something you can get in a, what you call first try itself. You do more and more questions. Once you do more and more questions, your brain will get adopted to think like a computer. So once you start thinking like a computer, and basically not thinking like a computer, think like a human. Actually, what happens in you all is you all are unable to think like a human. Okay. So once you are able to think like a human means think how your brain works. If you start thinking how your brain works, then creating programs very easy. See, basically that's how your brain works. Multiply the closer digit. After you're done with the multiplication, see what the next digit is. After done with the multiplication, see what the next digit is. So technically, what is happening in your brain, you're decoding it in a paper format. And that's how I figure out the answer. Make sense? Isn't it Q is greater than N? Or is it P is equal to N? Q is greater than N. When Q becomes greater than N, the repetition should stop. Because you can see logically that's what happened, right? As soon as Q became 6, 6 is what? A number greater than N. After it becomes 6, you have to stop the repetition. Because that's why you have 120 here stored. P is 120. How to getting Q, P equals P to Q and Q equals plus 1. It's decoding your brain. With practice, you'll understand. The first time you're doing a question, when you practice more and more questions, it'll make sense. Are these common questions? Yes. Fun fact, these are compulsory question. This is a question which I'm discussing here. It's not a selection question. It's a compulsory program question. How do we know how many times we should repeat? You know how many times you repeat. Basically, how you ask that question, you should know when to stop. Your question should not be how to know how many times to repeat. Your question should know when to stop. Like for example, running around the race, you don't ask your question, you don't ask your brain, How many times am I, like, you don't ask your brains, what do you call, how many times should I run? Okay, like for example, what you ask your brain is, when should I stop? The question you, actually, when you're running around the race, at the start point, you're asking a question from your brain, right? The question you're asking from your brain is what? Should I stop? Is it enough? Have I completed 4 rounds? Have I completed 4 rounds? Okay, so your question is when to stop. So you stop. If you, practically, when we did the calculation step by step, we have to stop when the entered, when the next number is equal to, is when the next number is greater than the number entered. See, when the next number was less than the number entered, we continue in the calculation, repetition. As soon as the next number became greater, we stopped and we like, okay, we have 120 already found. How do we get n equals 5? Go and watch the recording. I again told you. I again and again told you. That's an example again. When here also I mentioned the word called example. Let's consider n to be 5. Why plus 1? Then how are you going to figure out the next number? So you can see there's a pattern to figure out the next number. Right? Initially, when you multiply 1 times 2, if you had the answer as 2, to figure out the next number, you're going to go, okay, the number we multiplied, go over the next number. See, there's a plus 1. After you find 2 times 3 is 6. Once you have the number 6, now you to go, before you want, if you want to multiply the next digit, you can figure out the next digit by adding plus 1 to the number you multiplied. Again, plus 1 to the number you multiplied. So there's a pattern here. This pattern is what I decoded there. Can you take any number for n when you're testing? You're testing it. So technically in this situation, what's going to happen is P is going to be equal, so L is going to represent P into Q, and M is going to represent Q plus 1. Okay. Yes, Halima. How many of you actually got that L and M correct? Raise your hands up, let's see. None of y'all. Interesting. 1, 2, 3, 4. Okay, 5. Okay, second question is saying n equals 4. Write down the final values of P and Q in the algorithm Z. I'm pretty sure none of you all did this question properly. I want you all to draw this table, not like this actually. I want you all to draw the proper dry run. There's some columns missing in my dry run. What I'm drawing here is dry run, but I have omitted certain columns. I want you all to draw the dry run for the question B because majority of you did not do it. Do it in such that you have one column for the variable P, one for column for the variable Q, one column for the variable N, one column for the condition is Q greater than N, and one column for the output. Draw a table and fill the table by going through the program step by step. And in this question, they have said, for example, to consider n to be 4. Now, in my example, I said n to be 5. So here you are drawing the dry run, consider n to be 4, and draw the dry run all of it. Shana, you'll be getting a separate tutorials. I'll give you 5 minutes. Just draw the dry run. And once you're done drawing the dry run, raise your hands up. But if you first put all of your hands down first. Yeah, once you're done drawing the dry run, raise your hands up. The question requires a dry run, right? For question B, yes. So draw the dry run, which means like this, what do you call, have these columns as P, N, Q, N, and fill the table by following the instructions in this flowchart in the pattern, in how it's the exact order. I'm posting it inside this one, community, once the class is over. No, I'll check, wait. What's the answer for that question? That's why I'm asking you all to do the dry run. Once you do the dry run, you can figure out the answer. I give you 5 minutes to do the dry run. Once you're done, I'll do it. After that, should we separately mention values of P and Q? Yes. What if you draw a dry run in our exam and they mark it as wrong? They will not care about the dry run. You draw the dry run, find the answer. Like imagine the question was asking you, what do you called in this, let's say this was a question asked from you. If 5 was entered, what's the output? If you mention 120, you get the marks. But if you go and mention equals 5 times, 4 times, 3 times, 2 times, 1, you don't get the marks because that's the process. They want the result. So dry run is a process to find your answer. If you don't show them, if you want, you can show them the process. But after you are done with the process, you have to show the final answer. Yes, so after class. For the multiplication sign, there is no problem using x instead of star, right? There is a problem. X is not an operator. We call them as operators. X is not an operator. Star is the only operator. Zoha, you think you WhatsApp in a reply for that one? Okay, let's check. Example. Like for example, I'll again do the same question with the n to be 4. It's just example, man. All these for this answer. Not exact. Actually, you can do the whole question in mind. Like, for like, if I was in your situation, I will not do all these stuff. I'll do it in the mind itself. But again, it's risky. What's the meaning of M and L? That's what I found in the first question, man. Can't you see what I wrote here? L is represent P into Q. M is represent Q plus 1. That's what we found in the first question. That's what the first question they're asking. To figure out what is L and to figure out what is M. We have 40 seconds remaining. Only two of you are done. Others, once you're done drawing the diagram for the question B, raise your hands up in Zoom. Okay, I'm up. Okay, so you have the correct answer. Okay. If you look at the diagram, if you look at the program, the first question they are saying is input n, which means the program is asking, hey user, give me a value for n. It's asking, give me a value to store as n. In this question, they have said to consider n to be how much? For the example, I mean to find the answer, they have said, for example, to consider n as how much? The question has said what? Perfect. The question has said to consider n to be 4. So I'm going to consider n to be 4. Now I go for the next instruction. The next instruction is saying there's a variable called p, it seems, and there's a variable called q. P is going to be equal to 1. Q is also equal to 1. So I'm storing that as well. Then I have a condition. The condition I'm going to go and check is q greater than n. I'm going to go and check is the value of q greater than n. Normally, if you check a condition, always your answer will be like a yes or no answer or a true or false answer, right? Now, when I go and check the value of Q, you can see Q is 1, N is 4. If I go and check is 1 greater than 4, what is going to be the answer? Yes or no? Exactly. The answer is no. Now, if I follow the flow chart, if the answer is no, I have to go for the right-hand side instruction. In the right-hand side, I have an instruction saying the value of P is going to be equal to P into Q. Always keep in mind, when you get an equation, we are giving a value or we are finding the answer of who is in the left-hand side. We are finding the answer of the left-hand side person. So here in the left-hand side, we have P. So we are going to find what is the value that's going to come here. So we are saying the value that's going to come here is going to be equal to P into Q. If you look at the table currently, P is 1, Q is 1. So what is the answer of P into Q? Perfect. P into Q means 1 times 1. This is how much? Exactly. The answer is going to be 1. Once I'm done with that instruction, you go for the next instruction. The next instruction is saying Q equals Q plus 1. Currently, you can see Q is 1. So when you say Q plus 1, what will be the new value of Q? Again, same story. When you say Q equals Q plus 1, we are giving a value for Q. As in the new value of Q is going to be equal to the current value of Q plus 1. So currently, if Q was 1, we're going to say 1 plus 1, which means that's going to be 2. So Q is going to be equal to 2. And Q becomes 2. Likewise, you follow the line and go like that itself. You again come and check the question. The condition is Q greater than N. Q is 2, N is 4. You're going to go and check is 2 greater than 4. When you go and check is 2 greater than 4, what is the result? Yes or no? Exactly. Again, your answer is no. So because it's no, you're going to go for the next instruction. That's P equals P times Q. P is now 1, Q is 2. When I say P into Q, what is the value of P into Q? Perfect. 1 times 2 is 2. Next instruction is saying Q equals Q plus 1. Tell me, after I follow that instruction Q equals Q plus 1, what is going to be the new value of Q? Perfect. That's going to be 3 because 2 plus 1 is 3. Then you go for the next instruction is Q greater than N. Is 3 greater than 4? That's the answer. Yes or no? Exactly. Again, the answer is no. So because there's no, you're going to follow the line here and say no means you'll go right side. And right side we have P equals P times Q. Now when I multiply P into Q, what's going to be the new value of P? Exact. P is 2, Q is 3. 2 times 3 is 6. Next instruction I go is Q equals Q plus 1. After I follow that instruction, what's going to be the new value of Q? Perfect. Currently Q is 3. When you say Q equals Q plus 1, Q is you can say 3. 3 plus 1 is 4. Again, if you follow the instruction, go for the next one is Q greater than N. Q is now 4, N is 4. When you go and check is 4 greater than 4. Yes or no? Again, that's going to be a no. Because if you have 4 apples, your friend has 4 apples. Do you have more than your friend? No, you all have equal. It's not more. So the answer is no. Again, if you go for right side, P equals P into Q. Now when you multiply P and Q, what's the answer? 6 times 4 is 24. The next instruction we have is Q equals Q plus 1. After I follow that instruction, what will be the new value of Q? Perfect. That's going to be 5. After done with that, if you go for the next instruction is asking, is Q greater than N? Look at the current value of Q and tell me, when you check, is it greater than N? What's going to be the result? Yes or no? Is Q greater than N? Yes. 5 is greater than 4. Yes. If it's yes, you have to go for the down instruction. The down instruction has display P. So the current value of P is how much? P is 24. So the output is going to be 24. This is how the program works if the input is 4. Is that clear? First of all, tell me that if the input is 4, this is how the program works. Is that clear? Fine. Now, the question did not ask us what was the output. The question asked us when a program ends, when the program reaches the end, after this only program will reach the end. Don't we multiply 24 by 5 and put this output? Why should we multiply? Now, you saw me following the instructions, right? I followed the instruction there and noted it down here. Followed there, noted it down here. Did it come to a situation where we had to multiply those two? If you notice a pattern, I didn't fill the table randomly. Huh? I followed the instruction, the flow. I went in the order. I was again going. If you notice, that's why this is colored so many times. When I do the blue color coloring, it has to be the blue color here. If in orange color coloring, I went this side to the color pattern as well. I follow the instruction exactly. I followed the instruction there and noted it down here. Followed there, followed the instruction mentioned and noted it here. That's how I fill this table. So when I filled it last, I was going and saying is q greater than n. If it is 5 greater than 4, it was saying yes, and I ended the program. I came to display P. So when I say display P, the current value of P was 24. So that's why I display 24. So basically what you do is you follow the pattern there and fill it here. Don't just assume and write. Make sense? Should we draw a separate column in the dry run for Q? Last week, weren't you there? Go and watch the last week's recording. A dry run should contain all the variables. A dry run should contain all the conditions. A dry run should contain one column output. How did we get 120 previously? Nicely tell me in the previous time what I said to consider number to be how much? In the previous exam, I asked number to be how much? 5. So number is 5, then the answer is going to be 5 times, 4 times, 3 times, 2 times 1. It is 120. But in this example given here, for the question B, what is the value of n? Is it 5? No. N is how much? Well, how long are the recordings available? Lifetime. No expiry. It's 4 here. So because when the input is 4, output is 24. When the input is 5, output is 100. Make sense? Right. So the question is asking, write down the final values of P and Q. So if you just keep the answers, you don't get marks. You get marks only if you go and mention P is equal to 24 when the program ends and Q is equal to 5 when the program ends. Only if you mention this part, you will be getting marks here. Is that clear? All of you? Is it a must to draw the column on the exam? Fun fact, this is not, so dry run is not there in your syllabus. But without the dry run, if you're going to do this question, you're going to get confused. So just because you do the dry run, they will not give you marks. That's out of the syllabus to make sure that you know how to do these questions. So after you draw the dry run, answer what the question is asking. If the question is asking output, below the dry run, just write output is 24. If the question is asking what is the value of P and Q, just mean P is 24, Q is 5. So after you draw the dry run to find the answer. After you found the answer, tell what the answer is back to the question. No, Mohammed. No, Iman. We can finally mention the final answer without method. Yes, you can mention without the method as well. Because there is no method for this. This is like you're doing the brain technically. What I've done is I have put your brain into a paper. What is the answer for B? Yeah. So if you had mentioned this as answer for P, you get half marks. This is answer for Q, you get half marks. This is answer for L, you get half marks. This is answer for M, you get half marks. This is the answer for A. This is the answer for B. Put half marks each and tell me how much marks did you all get for this question out of 2. Because these are 2 marks compulsory question. Not a problem if it's shown in the answer. Yeah, you can show the dry run. That's not a problem. I would recommend you to keep the dry run on the paper. Don't erase it. They will not reduce marks, or they will not even take it. They will not even care about it. You just keep the dry run for the day. After that is over, just make sure you mention like these 2 points. Like this. Mention these 2 as well. What your exact answers. Just 2 marks for the entire question. Yes. And it's a compulsory question. How can we find the answer for A? Go and watch the recording. I was spending so much time to find the answer for A. You decode your brain. That's how you find the answer for A. Find how your brain works. That's how you find the answer for A. That's the part of programming. The art of programming is finding a solution. In program, you don't get money for what you call building products. You get money, the more money comes in when you solve a problem. If a person comes with you for a problem, The value is there, not the product you build. Because anyone can build a product. Even you can go and ask ChatGPT to build a product. Okay, if you want to build an app or something, there are several applications now. You can go and build. So the value is not there in end result. The value is there in your algorithm, basically in your process. How can we get the recording in the last class? I had posted in the community. I'll again post it today as well. Yes, just 2 marks. Do we need to suffer this? It's like this. This question does not just teach you how to find the answer here. It teaches you how to think in a different perspective. If you had listened to my whole conversation of how I explain about this whole scenario, how I found the answer for A, I indirectly am telling you how to think like your brain. This is not something you can get correct in the first try. This is still your first attempt. You practice, practice, practice. Then you start getting adopted to it. Okay, this is how you work. This is how it's work. This is how it works. And once you get used to it, it will make sense. When I'm thinking of keeping it on fourth and fifth. Let's see. That is a what do you call election? This. Let's see. Anyways, any other questions anyone having? So these are the answer for A and these are the answer for B. Will confusing questions come from this lesson like to meddle up? Obviously, programming is there to confuse you only. Confuse you means make you think. So you can get questions to think. Let's see one. This is an easy question. Easy question. I want a question where go ahead. Use your head. Use your head. Use your head. Okay, you want an easy question? Let's give you an easy question then. Fine. This is too easy, Baba question, man. It's too Baba. I will do that question, okay, but we'll keep it for another day. Okay, this is an easy question. Okay, this is nothing hard. You have to use your brains a bit, but this is an easy question. I think we have done this question in the class. In the class, I can remember like we did this question, but fine. I'll give you all 5 minutes to this question. Let me put the timer for 5 minutes. I'm going to put all of your hands down. Once you're done with this question, raise your hands up. I know we did this in the class, but again, do it. Those we did earlier. Are we supposed to get the tunes? You will be getting the tunes if you are coming to my theory class. Again, it's still on print, so you'll be getting it with the second lesson and third lesson too. Doesn't look easy, but it's actually easy. How long would the dry run and finding the answer all take for the question before? Maximum 2 minutes to 5 minutes, 3 minutes. If you know how to do it, you can draw it within 2 to 5, maximum 5 minutes, around 2 minutes averagely. I came too late, that's too late. I'll do this question also. It's an easy one. Let's do it again. If you did it earlier, again, do it. Don't just tell that day we did in the class, killer. Don't stop. If you're only joining the paper class, are you supposed to get the tunes? If you're getting only the paper class, how to get the tunes, I'll tell you later. Because still I did not get the tunes from the printers. After I get it, I'll let you all know how you get it. But my theory class friends, you'll be getting it with the theory tune. Others, only paper class people, I'll tell you later. For now, anyways, all of you have to maintain writing book. For now, so look at the question and in the writing book, I write the answers. Wait, okay. Exactly, it's a Baba question. Some of you know what is lesson going on in theory class. In the theory class, we're done with the first, Corona, we are done with the, Corona will be done with the what do you call first lesson coming week, coming Saturday. Vellavath Corona, see, Vellavath online will be done with the first lesson, I think, not coming week, next week. It is not the coming, not May 2nd. I think by May 9th, inshallah, will be done in online in Vellavath. So we start the second lesson. I'll be posting in the channel and I'm starting the second lesson. So just have a, what do you call, just look at the channel and wait. When I start the second lesson, I'll let you know. Within 2-3 weeks, we'll be starting. Online, we'll be starting the second lesson most probably the week after, not coming week, not after that week after, I guess. I'll confirm the channel, don't worry. Just join the channel. So there is basically you all have to be there in the paper class people have to be there in two places. You'll have to be there in the WhatsApp channel and paper class community. I'll send both the links in the chat. Just make sure that you are there in both so that you get the respective updates. So looking for the WhatsApp channel. Yes. And the community link is yeah. Copy. Next. You have sent it after class because I researched. I researched it as well. Paper community. Community is what is the best time to write code? Depends on what code you want to write. Python HTML. Visual Studio Code is good enough. Give me a minute. The time is up. Just give me a minute. Time is up. Just give me a minute. Okay, let's start. So they are saying the following algorithm is used to select players for rugby pool. The selection is done based on height, weight, and age of player. The height, weight, and age of player. Okay, fine. Let's start. Where is my pen? Okay, so height, weight of the three candidates are given below. Let's check. So what's going to happen here is they have mentioned here an algorithm. Again, algorithm means just a set of instructions on how to solve a problem. Simple thing. So they have told you how you can figure out if a person is qualified or not. Let's check one by one. First of all, let's take the fellow called Nirmal. If you take Nirmal, and if you're going to find, first of all, let's say we have replaced now. This you can see in this program we have something called age, height, weight, all those stuff now. Those are actually variables, right? So what we're going to do is we're going to replace those variables with the respective values, which means when you're going to check for Nirmal, We're going to replace with Nirmal's values. Nirmal's age is 21. So I'm going to write here 21. Nirmal's height is 159. So I'm going to write here 159. Nirmal's weight is 71. So I write here 71. Now let's say I'm going to check condition by condition. I go and check, is age greater than, okay, there's an order to follow here as well. Let me first what is the order. When you're performing a calculation, so in maths you would have learned the order you follow, right? What is the order you follow? When you're performing a mathematical calculation, which order do you follow when you're finding the answer? Exactly. You might follow the bottommost order. But when we are following what you called these questions, programming question, there's a different order you follow. First of all, you do brackets. If there's a brackets, first of all, you solve the brackets. Same order only, but the words I'm going to use are different. After brackets, second you give for exponential. Exponential like powers like 2 to the power 3, 3 to the power 4. That's what you call as exponential. No? So second priority you give for exponential. The third priority you give for division. Fourth priority you give for multiplication. And last priority you give for addition and then subtraction. But apart from these addition, subtraction, all those stuff, there are more operators we have. When we are learning about operators in programming, there are certain operators called as AND operator, or operator, not operator. So when you're giving the order, you give the not operator just after brackets. No, that's a different order. After brackets, you give next order for not. After not, the next order you give for AND gate, and the last preference you give for OR gate. Okay, in terms of what you called logical operators, this is how the order works. Now, based on that, you can see there is a bracket here. There is a bracket here. There is two main, inside the main bracket, there is two small brackets. So let's go with the first small bracket. If you go for this first small bracket and check, is age greater than or equal to 21? What is the result of this bracket? True or false? When you go and check, is 21 greater than or equal to 21? What's going to be the result? True or false? Because always keep in mind, when you're dealing with conditions, the result will be like true or false answers, like yes or no. Yes means true, no means false. Correct. That's going to give you true. Now you come for the second bracket. In the second bracket, we have two different conditions. So first of all, let's go for the first condition. Okay, this first condition we have here is height greater than or equal to 160. What will be the result of this condition? True or false? Yes, when you go and check is 159 greater, that's going to give you false. Then we have another condition here. Is weight greater than or equal to 70? What's going to be the result of this condition? True or false? Perfect. That's going to come inside true. Now, if you like expand the bracket and see, it will look something like this. We have true from that end, from that age part. This is coming in one bracket. Then you have the word called and. In the second bracket, we have false or false. If you notice properly, this is how we have it. Okay, you can see if you look at properly. In the second bracket, we have false or false. So false or true. Sorry, false or true. Second bracket, we have false or true. First bracket, we have true. Now you have to use the logic gate knowledge. In logic gate, you normally consider true as 1, false as 0. Okay. In logic gate, if you had 0 and 1 as inputs for OR gate, what will be the result of that? Logic gate, when you had 0 and 1, what will be the result? Result will be 1. Now, in 1 is normally represented, so true is normally represented by 1. For AND gate, if you have 1 and 1, what will be the result? And means like dot. So 1 and 1 means 1. And 1 is representing what? True or false? True. So now based on that, tell me, overall, this main bracket, what is the result of the overall condition? So true or false? Exactly. So overall, we are getting true. So if you are getting true, what should happen? You're going to output this statement. What is this statement telling? Qualified for the pool. So now based on that, we know Nirmal is qualified for the pool. Is that clear, all of you? Understood how I found the answer? Perfect. Now, when you use the same approach and find for the other people, like for example, let's say we go and find for Rajiv. If you take Rajiv, Rajiv's age is 36. So if you go and check, is 36 greater than 21? Yes, true. So that bracket is going to give you true. Then you have the AND operator and the second brackets. So second bracket first one is height greater than or equal to 160. Is his height greater than or equal to 160? That's going to give you true. Then or then we have is his weight greater than or equal to 70? Weight is 72. That's also going to give you true. Now you find true or true means result is true. True and true, also result is true. So overall result is true, which means you're going to go and follow the first instruction. So Rajiv is also qualified. Same thing if you go and check for Salim. Salim is here. So Salim, if you take his age is 25. If you go and check is 25 greater than or equal to 21? True. Then you have the AND operator. Then his height, is it greater than or equal to 160? Is his height greater? No. So that's going to give you false. Then you have the OR operator. Then you have is weight greater than or equal to 70? Is his weight greater than or equal to 70? No. False. Now you can see these two conditions false or false. Result is false. Like imagine OR gate 0 and 0 is 0. Now you have a true and false. Tell me for AND gate, if one of the input is true, other input is false, which means one input is 1, other input is 0. What will be the result of the AND gate? Exactly. If one input is 1, other input is 0. Or if one input is true, other input is false, the result is going to be 0 or the result is going to be false. So if the overall condition is going to give you false, you go for the else section here, and that is saying output not qualified for the pool. When you say not qualified for the pool, that means Salim is not qualified. So the answer for this question is write down the names of who are qualified. Qualified are Nirmal and Rajiv. How many of you all got their answer correct? Raise your hands up, listen. Others, is it clear how I found the answer? Yes or no? Nirmal's age is not greater than 29, 21. How is it true? Nirmal's age. The question is asking, is 21 greater than or equal? When I ask, is it greater than or equal? You ask the decoding this question, we are checking, is 21 greater than 21 or is 21 equal to 21? When you go and check, is 21 greater than 21? Is it greater? Is it greater? No. So that means false. When you check, is 21 equal to 21? True or false? True. Now when you use the word called or, false or true, what's the result? False or true is true. So that is why we got true here for that first condition. In this one, yeah. That's how this true came. Why is Salim not qualified? I don't understand the part only. Can you explain the part again? So when you take Salim, why he is not qualified is if he wants to get qualified, the overall condition is that the main bracket has to give you true. When I decoded this, the first bracket is age greater than 21. That bracket gave me true. When his height greater than or equal to, that gave me false. When his weight greater than or equal to, that gave me false. So now when I'm going to find the result, when we have false and false with the OR operator, this will result in false. Is that part clear? Understand how this green color false came? Perfect. Now the true will come down as it is. When you have true and false, using the AND operators, tell me for the AND operator, again logic gates. For logic gate, imagine you have one of the input is 1, other input is 0. What will be the result? 0 or 1? 0. And 0 is representing what? True or false? False. So that means this overall condition we have here, this thing which we have here, the overall condition is giving you false. Now if you notice, this is an if statement. If condition, then something else something. That's how the structure is if, and then you have a condition, then you have the word called then, and you have some instruction, else, and you have some instruction, and end if. This is the structure of a selection structure. So how the selection structure works is you go and check the condition. If this condition gives you true, you follow the top instruction in between then and else. If the condition gives you false, you follow the bottom instruction in between else and if. So if you notice for Salim's scenario, Salim's overall result was false. So that's where you follow the instruction after else. Make sense? That's why we said Salim is not qualified for the pool because the overall condition gives you false. Because it gave false, you went for the part after else. Got it? Exactly. Salim needs to get some root. We can attempt to this without logic gates also. This operator is called logical operator. Logical operator means it's the basic same idea of logic gates. Perfect. Okay. For today, actually, we're done with there. But before we wind up, is there any questions anyone have? If you have any questions, you can stay and ask. Others, if you don't have any questions, you can leave. We're done for the day. You said you will teach that lesson. I thought about logical operator in the class. But it's a separate thing. Maybe I want to do, let's say. I might do, let's say. Anyways, anyone have any questions here? If you have any questions, stay and ask. Don't have any questions, nothing. We're done for the day. When will you put the recording? Once the class is over, just give me 5 10 minutes. After the class, I'll put it. What is the theory class time? Below 5 to 7 5 days. How long does the recording last? Lifetime. No deadline. But what should in 1 week? Even though I give you all so much time, is what you what's up? Inshallah. Height and weight was given one brackets, right? Here I replace the values, the tables values. Umar, what's up, please? Okay, as there's no other questions, I'm going to wind up. But if there's any questions or clarifications, just WhatsApp to the other number, okay? This number, the new number. And I'll get back to you. And I'll post the recording in all this PDF or in that community. Yeah, so with that, we're done. And have a nice day.